Hello everyone. In the previous lecture, we have seen the homogeneous functions and we have also defined the homogeneous differential equations. I think we had also seen how to solve a homogeneous differential equation. Okay, in this lecture, we will take up a few examples on solving the homogeneous differential equation, finding the general and particular solutions of a differential equation. Okay, so there is a problem here. Show that the differential equation x cos of y by x dy by dx equal to y cos of y by x plus x is homogeneous, and solve it. Solve it in the sense they are asking us to find out the general solution. So first we will write down the differential equation. We have x cos of y by x into dy by dx equal to y cos of y by x plus x, right? Now, what is the first step? Express f of x comma y as g of y by x. Okay, first we have to, in order to get f of x comma y, we have to first write it in the form of dy by dx equal to f of x comma y. So I will keep dy by dx here itself. So what will I get? Dy by dx equal to, I will get y cos of y by x plus x divided by, I will get x cos of y by x. Fine. So now once I have it, the first step says express the f of x comma y in the form of y by x. Now, but before doing that, I mean before solving that, they have asked to show that show that this is a homogeneous differential equation. How will I show that this is a homogeneous differential equation? And for time being, I'll call it as equation 1. Okay, what I will do is I will let this RHS, okay, this particular RHS as f of x comma y. Okay, yes, I will let this to be f of x comma y. F of x comma y equal to what? F, I mean y cos of y by x plus x divided by x cos of y by x. Okay, so how will you check whether this is a homogeneous function or not? I will just put f equal to lambda x, I mean x equal to lambda x and y equal to lambda y. What will I get? I'll get lambda y times cos of lambda y by lambda x plus lambda x divided by, okay, lambda x cos of lambda y comma lambda x. Fine. So once I have it, ಇದರಲ್ಲಿ first term is this, second term is this. ಇದೆರಡರಲ್ಲೂ lambda common ಇದೆ. If I take out lambda, what will I get? I will get cos of lambda cancel again. I will again get y by x. No, y is also left out here. Y cos of y by x plus lambda ಹೊರಗೋಯ್ತು. I will get x whole divided by, okay, lambda ಇಲ್ಲೇ ಇದೆ, x cos of lambda cancel ಆದರೆ I will get y by x. Okay, lambda divided by lambda ಇದೆ, ಎರಡು cancel ಆಗಿ I'll get 1 can be written as lambda raised to 0. Okay, lambda raised to 0 times y cos of this is nothing but our f of x comma y, right? So therefore I can write it as f of x comma y. So what did we get? We got f of lambda x comma lambda y is equal to lambda raised to 0 times f of x comma y. Therefore we can say that f of x comma y is a homogeneous function of degree 0. The homogeneous function of degree 0. If f of x comma y is a homogeneous function of degree 0, then we had defined, if f of x comma y is a homogeneous function of degree 0, then this differential equation of the form dy by dx equal to f of x comma y is called as a homogeneous differential equation. So therefore, since this is a homogeneous function of degree 0, I can say that this equation 1 is a homogeneous differential equation. So this implies equation 1 is a homogeneous differential equation. So show that the differential equation is homogeneous. This part is done. Okay, this is already done. Now what we have to do is we have to solve it. Okay, to solve it, I will consider the first step. The first equation. Consider the differential equation dy by dx equal to, I think, y cos of y by x y cos of y by x plus x whole divided by, okay, y cos of y by x plus x divided by x cos of y by x. Okay, so now what I'll do is I will follow the steps. First step is given by this, that is express the function as the function of y by x. So I have told you how to get it done. Take the highest powered term of x and divide it throughout. Okay, ಇದರಲ್ಲಿ x ಇದೆ. Okay, if I divide every term by x, what will I get? Dy by dx equal to, I'll get y by x into this cos of y by x will remain as it is. Okay, plus x ಗೆ x ಇಂದ ಡಿವೈಡ್ ಮಾಡಿದ್ರೆ 1 whole divided by x ಗೆ x ಇಂದ ಡಿವೈಡ್ ಮಾಡಿದ್ರೆ 1 remaining cos of y by x will remain as it is. Fine. Okay, so now you can see the entire differential equation ನಲ್ಲಿ right hand side is the function of y by x. Okay, y by x ಬಿಟ್ರೆ ಬೇರೆ ಯಾವುದು x separate y separate variables ಬಂದೇ ಇಲ್ಲ. Okay, once that is done, they are saying put y by x equal to v. Okay, so now what I will do is I will just put y by, I will call this as equation 2. Okay, y by x equal to v. This implies y is equal to xv. If you differentiate both sides with respect to x, what will I get? I'll get dy by dx equal to derivative of x is 1, so v as it is, plus x as it is, derivative of v is dv by dx, right? So once this is done, I will substitute this in the equation 2. Equation 2 implies dy by dx. Dy by dx is equal to what? We have got v plus x dv by dx. V plus x dv by dx is equal to, on RHS if I substitute, I'll get v cos v plus 1 divided by cos v, right? Now you can see I can split this one, right? So if I split it, now of course we have to bring all the v terms to one side and all the x terms to the other side. So what I'll do, I'll bring this v to the other side because every term here is in terms of y, so v, so therefore x dv by dx equal to, I will split it first, v cos v and cos v will get cancelled out, plus 1 by cos v. This plus v, if it comes to the other side, it will be minus v. V and v will get cancelled out, so I will get x dv by dx is equal to 1 by cos v. Okay, so this will give me ಈ v ಈ ಕಡೆ ತಗೊಂಡ್ರೆ I will get cos v dv is equal to x ಈ ಕಡೆ ಬಂದ್ರೆ 1 by x dx. So therefore if I integrate on both sides, left hand side with respect to v and right hand side with respect to x, I will get this. Okay, so this will give me, what is the derivative of cos x? It is sin x. So therefore, sorry, integral of cos x is sin x. So therefore the integral of cos v is sin v equal to, I have told you, just write the integration constant either on left hand side or on right hand side. Okay, no need of writing it on both sides. Okay, I'll get sin v equal to 1 by x, the integral ಏನು ಅಂದ್ರೆ log x, we'll consider it as log mod x plus c. Okay, so this is the general solution, but we have to replace v by y by x, so therefore sin of v andre y by x equal to log mod x plus c. So therefore this is the required general solution. So this is the required general solution that we have. Okay, so first what we did, we will express the function in the form of dy by dx equal to f of x comma y e formally, and then we will take out f of x comma y, we will substitute x equal to lambda x and y equal to lambda y. We will first prove that this is a function of, homogeneous function of degree 0. Obviously automatically it is implied that equation 1 is a homogeneous differential equation. Once that is done, we will substitute y by x equal to v. Okay, and then we will convert it into a homogeneous differential equation, sorry, a variable separable differential equation. Once that is done, we will separate out all the v terms and x terms, and we will integrate left hand side with respect to v and right hand side with respect to x, and then we will get the general solution. The general solution will be in terms of v, so therefore whenever we get v, we will have to replace it with y by x. Fine. So this is how we will solve a homogeneous differential equation. Okay, we will take up one more problem which is based on the particular solution. Okay, so let's go for the next question. So here is the next problem. We have to find the particular solution of this differential equation, what is given, and the conditions are also given. Now look, they have not asked us to show that this is a homogeneous differential equation. So the first part, what we did, putting x equal to lambda x, y equal to lambda y in the function, and then saying that it is a homogeneous function of degree 0, all those things are not required. So what we have to do is, we will just have to find the general solution and then substitute the conditions, constant find ಮಾಡಿ, and then we will have to find out the particular solution. So we will come to this. Okay, we will write down the given differential equation. X, what is the given differential equation? X sine square y by x minus y into dx plus x dy equal to 0, right? So this will give me, if I take, let's say, ಯಾವ್ದಾದ್ರು one term ನ ಆ ಕಡೆಗೆ ತಗೊಂಡು ಹೋದ್ರೆ, what will I get? I'll get x dy ಇಲ್ಲೇ ಇಟ್ಟು ಇದನ್ನ ಆ ಕಡೆಗೆ ತಗೊಂಡು ಹೋಗ್ತೀನಿ. ಮೈನಸ್ ಆಗೋ ಬದಲು ಈ ಎರಡು ಟರ್ಮ್ಸ್ ನಾನು ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡ್ಕೊಳ್ತೀನಿ. ಸೊ ಐ ವಿಲ್ ಗೆಟ್ y minus x sin square y by x, okay, into dx. So dx ಈ ಕಡೆಗೆ ತಗೊಂಬಂದು x ಆ ಕಡೆಗೆ ತಗೊಂಡಿದ್ರೆ ಐ ವಿಲ್ ಗೆಟ್ dy by dx equal to y minus x sin square of y by x whole divided by x. This is what I get, right? This is the differential equation that I have. What is the first step that we have seen? The first step is express this function as a function of y by x. Okay, now ಹೇಗೆ ಹೇಳಿದ್ದೆ, every term ಅನ್ನ x ಇಂದ ಡಿವೈಡ್ ಮಾಡಿ. Okay, ಅದನ್ನು ಮಾಡಬಹುದು. In this case especially, we can also split the terms ಅನ್ನ ನಾನು ಸ್ಪ್ಲಿಟ್ ಮಾಡಿದ್ರೆ y by x ಬರುತ್ತೆ ನೋಡಿ. ಅಂದ್ರೆ y by x minus x cancel ಆಗಿ I will get sin square of y by x. So that's all. ಇಲ್ಲಿ ನೋಡಿ, ಇಲ್ಲಿ y by x ಇದೆ, ಇಲ್ಲೂ y by x ಇದೆ, so it is a function of y by x overall. Okay, now the next step is to put y by x equal to v. So this will yield me y equal to xv. ಇದನ್ನ ನಾನು with respect to x differentiate ಮಾಡಿದ್ರೆ I will get dy by dx equal to x derivative 1 v as it is plus x as it is, derivative of v is dv by dx. Okay, so therefore ಇದನ್ನ ನಾನು equation 1 ಅಂತ ಕರೆದ್ರೆ equation 1 gives what? dy by dx left hand side ಇದೆ, that is v plus x dv by dx equal to y by x ಅಂದ್ರೆ v minus sin square y by x is v again. Okay, ಈ v ಮತ್ತೆ ಈ v ಎರಡು ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತು. So this will give me x dv by dx is equal to minus sin square v. Okay, minus sin square v ಈ ಕಡೆಗೆ ತಗೊಂಬಂದ್ರೆ ಡಿವೈಡ್ ಆಗುತ್ತೆ along with minus. So 1 by sin square v is cosec square v dv is equal to, ಇದು ಈ ಕಡೆಗೆ ಬಂದ್ರೆ I will get 1 by x dx. Okay, so I will integrate this on both sides. What will I get? I will get minus, what is the integration of cosec square v? We know that the derivative of cot x is minus cosec square x, right? So when you differentiate, so therefore when you integrate minus cosec square x, you should get cot x, right? So therefore what is the integration of minus cosec square x? It is cot x plus cot x. So it is plus cot v equal to log mod x plus c. So that is what you have. I will call this as equation 2. Equation 2 now is the which solution? It is the general solution. Therefore equation 2 is the general solution. Okay, Now to find the particular solution, we have what is given, the conditions ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡಿ, y equal to pi by 4 when x equal to 0, right? Y equal to pi by 4 when x equal to 0. So therefore equation 2 ಏನು ಹೇಳುತ್ತೆ, equation 2 gives okay, ಇಲ್ಲಿ v ಇದ್ದಲ್ಲಿ ನಾನು y by x ಹಾಕೋಬೇಕು, I had forgotten, sorry. Okay, so that I think we can manage. So we'll get cot of pi by 4 by 0. Okay, pi by 4, no, I think not 0, what they have given, when x equal to 1, when x equal to 1, I'm sorry, x equal to 1. So pi by 4 divided by 1 is pi by 4, so I'll put pi by 4 equal to log of x equal to 1 plus c. Log 1 is anyway 0, so cot pi by 4 is 1, therefore c is equal to 1. Hence the particular solution is, what will be the particular solution? The particular solution will be same as the general solution along with the value of c. Okay, the particular solution is cot of v anta ittu, that is y by x equal to log mod x plus c is plus 1. Okay, so this is the required particular solution. Okay, in the textbook what they have done is, andre ಇಷ್ಟು ಮಾಡಿದ್ರು ನಿಮಗೆ ಮಾರ್ಕ್ಸ್ ಸಿಗುತ್ತೆ, ಮಾರ್ಕ್ಸ್ ಸಿಗಲ್ಲ ಅಂತ ಅಲ್ಲ. In the textbook this is optional. Okay, the textbook what they have done is they have written down 1 as log e. Log e to the base e is always 1. I mean log a to the base a is always 1. Okay, remember this property. They have expressed it this way, and then they have written it down as cot of, see, this much is sufficient. You can do it only until here, fine. If not, this is optional. This is optional. If you want to simplify, otherwise you leave it, not at all a problem. Okay, cot of y by x equal to log mod x plus 1 can be written as log e. Okay, so log a plus log b can be written as log ab. I will write it down as log ex or xe. So this will give a cot of y by x equal to log of ex. Okay, so this is the particular solution. You can also write it as log cot of y by x equal to log x plus 1, or you can write it as cot of y by x equal to log ex. Okay, so this is how you can find out the particular solution of a homogeneous differential equation. Fine. I think there is an MCQ in the textbook. We will check it out. Okay, we'll go to the textbook. In the exercise 9.4, as you can see, at the last you have one function that is given. Okay, illi, that is the 16th one. The function is h of x by y. Okay, and you can see the dx by dy equal to h of x by y. It is as good as writing dy by dx equal to some g of y by x. Okay, illi dy by dx ide, illi y by x ide, illi dx by dy ide, illi x by y ide, right? In order to, now we will just see what they have asked us. Okay, the homogeneous differential equation of the form can be solved by making the substitution. Of course, as I said, x by y equal to v in this case. Okay, so x will be equal to what? Vy or yv. What is the answer then? The answer is equal to c. Okay, there is one more such question in the exercise, if I rightly remember. I think it is question number 10. Yes, so in this case also you will have to put x by y equal to v. Okay, and then x will be equal to vy. You will have to differentiate with respect to y. You will get dx by dy equal to v as it is, derivative of y is 1, plus y as it is, derivative of v is dv by dy. Okay, and then the remaining things will follow. You will have to separate out the v and y, integrate with respect to v, integrate with respect to y, and then substitute v equal to x by y back. Okay, so this is all about the homogeneous differential equations. In the next lecture, we will start with the linear differential equations. Okay.